Sir, I had a few questions about science.
Asking me?
Yes, sir.
Yeah, go ahead.
Sir,
Good evening, sir.
good
Hello, good
evening.
evening.
Oh, good evening.
Good evening.
Good evening, Udayji
Good evening. Campus.
and Aryan.
Yes, sir.
With Aryan or Rudra?
Sir, it's me, Aryan.
Okay.
Okay, sir. So I had the previous question of what changes in an AC when we change its temperature.
You are actually changing the thermostat, the thermostat setting of the AC basically.
Yes, sir. So what
So
happens?
at what temperature the compressor should kick in?
So, sir, what changes in that AC then?
You are asking uh, thermostat setting. Okay, within the thermostat setting you are looking for.
Yes, sir.
So it actually tells you. Okay, so you are looking more from the capacitor and other perspective. Correct? The electrical functioning of that thermostat. What is your actual question?
Sir, I think so. The one that Malik Sir mentioned, Jean Thompson law, where we pass air through a compressed point, a pressurized point, and then after some times, what happens? It cools down with the distance. So I'm talking about that. So what change? What would change in that specific case?
So when you set lower temperature, what is basically is asking thermostat the compressor to stay on for a longer duration, so that cold air is passed for a longer duration till time uh, the room temperature reaches that particular setting. Once the room temperature reaches the setting, it actually trips off. So it tells compressor stop sending cold.
Uh,
Udayji, actually, this question he had asked last time,
Yeah.
and I had made just a guess. I thought I will look into the present day ACs. So, yeah, Aryan, I think that is another way, which Udayji is telling, that number of time when the compressor is on. What I guessed is that the pressure is what is getting controlled, but I'm not sure. I just made a guess, and I'm
oh,
sorry I didn't go into didn't read this whole week.
okay, sir.
But yeah, what Udayji is telling, that's also one way to do it, and maybe that is the way. Yes, Aryan, but to me you should give me a time. But if Udayji has an answer in present day ACs, how they control the temperature.
Yes. So, sir,
Actually, one more thing I'll just say. Actually, the same problem can have a different answer if depending on what aspect of the problem you're looking at. So same problem could have multiple right answers. That's why
okay. But sir, I think so. If we hit something with the same temperature, uh, wouldn't that go up or would remain the same?
okay. So how so what is happening is, let's say at a particular temperature. I'll talk about Celsius because in India temperature setting as Celsius. Okay. So let's say room temperature has been set at, I don't know, 22 degrees Celsius. So the compressor is on if the room temperature is more than 22 and the cold air is pushed inside the house to bring the room temperature. Now, for it to trigger a switch off, the temperature of the room has to go below 22 degrees. Till the time the temperature of the room is less than 22, it will be off. The moment the temperature crosses 22, so there will be a window, small window, plus minus 22 degrees Celsius, where this particular thermostat will trip, like what happens in geyser and other places. So the moment the temperature crosses a particular limit, let's say setting is 22, the moment the temperature goes below 22, let's say 20, 21.5, I'm just making up that number, the compressor will stop working. That means there is no cold air being pumped into the house. And it will remain that way till time temperature crosses 22, means it is, let's say, 22.5. The moment the temperature is 22.5, again, the thermostat will sense that temperature has crossed its threshold limit and it should start the compressor. So there is a small window in which it will trip in and trip out.
Oh, okay, sir.
So actually, the water air that is coming out of the compressor is colder than the room temperature. Okay, and that's why it brings down the room temperature. And when it is switched off, because
Okay,
of the leakage and other thing, because we are not working in perfect condition, the room temperature again will go up.
okay, sir.
इसमें उदय जी खाली मेरे मन में जो डाउट था कि कंप्रेशन को फ्रीक्वेंटली ऑन ऑफ करना इज इट वेरी इजी जॉब इज इट
एक्चुअली में डिफिकल्टी नहीं है, क्योंकि कंप्रेसर को ऑन ऑफ करने के लिए इलेक्ट्रिकल करंट चाहिए उसको, which current is controlled by the setting of the thermostat. So the current is provided, you provide a current and you को एक्चुअल मैकेनिज्म तो पढ़ा नहीं मैंने, तो देखना पड़ेगा. But what comes to mind is the thermostat must be tripping the current and must be allowing the current to pass. The moment current is passed through to the compressor, it will start working. The moment the temperature is crosses a limit, the current is stripped and there is no electrical current.
In fact, last time I told him that I use for my cooling my insulin, I use a fridge which is 5 inches by 5 inches by 3 inches, sorry, 4 inches. So there it uses the current. Some materials, they decrease in temperature when the current flows through the joints. So that is a very also interesting way, but that's not utilized in the ACs because that's very inefficient.
Okay, sir.
Actually, purpose is different.
Yeah, because in a small volume, they cannot put in a compressor and things like that.
Okay, sir. So, sir,
Yes, Aryan, Abhi, you have a look at it. If you are not satisfied, you can repeat your question next time.
okay, sir. So, sir, on the back of my fridge, there is written that RC blowing up material. So, uh, how can that blow up? It's just a compression. How would that blow up?
What
In
blows up? What's written?
RC blowing up material, I think so.
RC.
Yes, sir.
What is RC?
Sir, I don't know.
RC
So
means
same
what? Remote
abbreviation could have
control.
different meaning. So
RC माने remote control हुआ क्या?
Sir, I don't know. It was just written on the back of my fridge.
Okay, those are proprietary words by the companies. But blowing material, RC blowing material.
Yes, sir. Uh, It was written that.
ये हम भी देखते हैं मेरे फ्रीज में क्या लिखा हुआ है देख करके अगली बार बताएंगे आपको.
Okay.
तो किस चीज पे लिखा हुआ है ये जो चीज आप बता रहे हो, किस पे लिखा हुआ है, मतलब इसके कहाँ पे लिखा
Sir, fridge की बैग पे.
है? इस फ्रिज के बैक.
Yes, sir.
नॉर्मली आर का अगर रेड है तो रेड कलर तो लाइव वायर का होता है, ठीक है, किसी भी इसमें। और उसका क्या लिखा है, ट्रिप्टॉफ क्या लिखा है उसका, आरसी
RC blowing material.
तो बेसिकली वो ट्रिप ऑफ, मतलब लाइव वायर जो ट्रिप ऑफ हो जाता होगा मेरे को लगता है एट अ पर्टिकुलर टेम्परेचर जो भी है, या कुछ फ्रिज को सेफ रखने के लिए जो लाइव वायर है वो ट्रिप ऑफ हो जाता होगा।
Okay, sir.
Udayji, did you hear about that crash landing of the one of the rockets of the
Yes.
Elon Musk? ये रॉकेट तो मून पर छोड़ा गया था क्या, कि ये तो अर्थ के ऊपर छोड़ा गया था ना?
हाँ छोड़ा गया था, लेकिन मैंने उसको ज्यादा फॉलो अप नहीं किया।
हाँ, पर जाकर के मून पे पहुंच गया वो। मैंने, is it that intentionally it was done or was it a that I
पता नहीं
in the
है।
newspaper that it came out, nothing is written that it was intentionally diverted to crash land there, because had it crash landed on Earth,
लेकिन इतना ट्रांजेक्टरी कैसे चेंज करेगा एनालिसिस का, कुछ पहले से सेटिंग ना हो। हाउ कैन यू, मतलब कि अगर उसको क्रैश ही करना है उसका ट्रांजेक्टरी इतना कैसे चेंज हो जाएगा, क्योंकि ट्रांजेक्टरी चेंज करने के लिए तो आपको बूस्टर चाहिए उसको।
बूस्टर तो चाहिए,
हाँ,
या
तो
बूस्टर
अगर वो
तो
चीजें
चाहिए।
प्लान तरीके से ना हो तो अगर अर्थ की जगह मून पे पहुंच जाना तो पॉसिबल नहीं है, क्योंकि डिफरेंस बहुत ज्यादा है। अंटिल अनलेस मून पे ही जाना था और क्रैश कर गया है।
But I did not read them. But he sent the rocket to the moon.
दैट ओनली मेक्स अ लॉजिकल दिस थिंग ना, अंटिल अनलेस वो मून को ना भेजे। नॉर्मल थोड़ा पाथ भी चेंज करने के लिए आपको, जिस पाथ पर सैटेलाइट चल रहा है या रॉकेट घूम रहा है, आपका उसका ट्राजेक्टरी थोड़ा भी चेंज करने के लिए आपको एक बूस्टर चाहिए। और ये तो मून पे तो बहुत ही ज्यादा है, मतलब स्पेस और मून का तो जमीन आसमान का फर्क। लो अर्थ जो है जनरली अराउंड 800 किलोमीटर है, जो स्टेशनरी 36,000 किलोमीटर है, और मून इज अराउंड 3 लाख किलोमीटर। तो अब परसेंटेज टर्म में देखिए कितना का डिफरेंस है। तो अंटिल अनलेस आपको कुछ किलोमीटर का चेंज करने के लिए बूस्टर चाहिए, उसके बिना नहीं हो सकता। तो इसको मून पे ही भेजा होगा और क्रैश लैंड कर गया होगा, जैसे कि रशियन रॉकेट किया था। देख रहा हूँ इसका, स्पेसएक्स रॉकेट पीस फ्लोटिंग इन स्पेस लास्ट ईयर smashed into moon at a high speed on Wednesday morning, joining the ranks of meteorites they had since लेकिन ये इसके बारे में पढ़ना पड़ेगा, क्योंकि ये जो है इट डज नॉट मेक सेंस। ये तो कोविड, ये कोरोना वायरस की तरह ही है कि हाँ, चीजें बोला गया नेवर मेड सेंस, एंड सब लोगों ने सवाल किया तो उनको पढ़ गंवा कर दिया, और आज के डेट में सभी लोग कह रहे हैं कि हाँ डज नॉट मेक सेंस कि वो मसले वैसे ही है। हाउ कैन द डेब्री लैंड अप इन द मून ग्रेविटेशनल पुल
Yes.
until unless is closer to moon, मतलब कि मून का ग्रेविटेशनल पुल क्लोजर टू मून ज्यादा होगा, क्लोजर टू अर्थ से मून कैसे खींच लेगा उसको।
Yes. So I have a few more questions.
तो
So whenever we burn something, there's an upper light on it, that golden brown light. So why does that occur? Why doesn't that go further? That light,
go further means further than what?
like it only has a small cone of light. uh, whenever we burn something, there's a small cone of light and it stays there. But why doesn't it go further outwards? Like how does it intensity gets so much dropped?
Sorry, Aryan, I missed your question. You can just repeat once, just.
So my question was that whenever we burn something, there's a golden brown light on it, right? Why
Right.
doesn't that light spread out further? How does that intensity of light decrease so fast?
So when burning what? Burning wood,
Anything
burning oil, what type?
like when I burn the diyas, I see that the deepak and diyas. Whenever we burn them, we see that.
So basically, you're burning because the type of compound which is will be generated by burning will be different. Burning wood will be different from burning oil.
Yes. Uh, so is that because of the inverse square law that its intensity dropped so further that we cannot catch that?
No,
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 it
no,
will.
no, 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 not at all. No, no. You see, the flame burns only up to, you see, whichever material burns is getting first vaporized, and the
Yes.
vapors have to travel, and vapors have to get high high temperature, to give a flame. तो जहां तक वो वेपर पहुंचता है वहां तक वो फ्लेम रहता है उसके बाद तो abruptly ending all the flames. This is my say. Udayji, you have to say something about it.
No, no, that's correct. Actually, there are as far the color is concerned, there are two things happening. One is the size of the flame. So depending on the amount of energy is getting from by burning whatever it is, oil, food, or whatever it is, it will go to a particular height. And color will also depend on lot of impurities around it. So by burning wood will create a different compound. So it will have a different color. Burning something else will have a different burning wax or this thing. So or burning a wick of a diya, it will have a different color. So depending on what we are burning, depending on the impurities that is there, it will develop a particular type of color.
Okay. So
Yeah.
like
So Aryan, you know that what Udayji told you that depending on the material, the color comes, and how far it goes depends on how far that the thing which is getting vaporized, how far it is traveling. That shape which comes, because of that, like
yeah,
this, yeah,
if light
the
was a wave,
sideways it doesn't go. You see, you'll find the flame. The sideways, the vapors don't go. The vapors try to go up. You will find the flames usually are not elongated on the sides. They are upward.
yes. But sir, if light was a wave, it should have traveled more outwards, isn't that?
So
Not
temperature
light.
will
It
also
is the
matter.
vapor of that material. The light is coming because that vapor is getting high temperature and emitting light.
But sir, I thought that it's because of the breaking bonds in, like, it's burning, it's releasing chemical, it's releasing energy from the atoms and all of these things. So that releases light.
Yeah, it's the temperature getting higher, so that the de-excitations take place because of the either breaking the bond or whatever it is. It is basically de-excitation of the electrons which takes place and which is emitting the light, characteristic light of that material.
Yes, sir.
Second thing, when you are talking about moving up, anything which burns, that means there is temperature goes up and temperature and pressures are inversely proportional. So when temperature goes up, pressure will come down. And anything where the pressure comes down has to go up. So hot air will also always travel up and cold temperature or cold air will always travel down.
Yeah, yeah, that's yeah, that's a good one. Yes.
Okay. But I still did not understand why should it care about the vapors. It's because of the atoms excitation and de-excitation.
Yeah, of course. Yeah, I meant the vapors means atoms, molecules only. Not,
That's why I said depending on the material that we use, there are different type of chemicals which will be released, and that will have their distinct color.
So I wasn't talking about the color. I was talking about why doesn't it spread out further? If light would have been a wave, it would have spread more further. Like
Light
it's
and
just,
fire are different. Light and fire are different things. Okay.
but
We are
said
talking
light,
about
but said the
the
light
fire.
we saw was photons, right?
So that it does not have enough intensity to move further than a particular place. And what you are talking about is not is the fire which is giving you limited amount of uh, light.
Oh,
So what is moving up is actually the fire. What color you are seeing is because of the burning of that particular material that is giving you that particular color. The light coming out of that particular burning fire is very limited.
okay. So the intensity of the of that light is not enough to travel further.
Yeah.
Okay. I also thought that.
आज अमरनाथ जी दिखाई नहीं पड़ रहे हैं, क्या बात है पंकज जी?
सर ये उनका ऑपरेशन हुआ।
क्या हुआ है?
ऑपरेशन
वो ही दिन
सर्जरी
सीरियस कब हुआ है?
2-3 इस थर्सडे को।
अच्छा,
मुझे भी नहीं पता।
वो अच्छा ठीक है, हम फोन कर लेंगे। क्या स्टेंट लगा है? वो डर रहे थे कि उनको स्टेंट लगेगा, बोल रहे थे।
नहीं सर, ओपन हार्ट सर्जरी हुआ है उनका।
ओ माय गॉड,
अभी आईसीयू में है।
ओहो,
मतलब सर्जरी हो गया लेकिन फिर भी उनका अभी आईसीयू में रखा हुआ है।
ओहो, you have to phone him now only after some time. चलिए, अर्थ, you have any question? Hello, Earth.
Yes, no sir.
But Aryan, it's nice you are bringing questions which are daily life questions.
Yes. Okay, sir.
What his thing is, Aryan question is actually stems from that inverse square law. So logically speaking, light should travel a lot, but because of intensity, this actually died down. It does not have the required amount of intensities for us to see. So over a period of time, even though light photons may be traveling, we can't see it.
Yes, sir. Sir, according to the inverse square law of light, if I point a beam of light into the sky, we should be able to see it like at for a pretty good distance. But I don't think so. We can do that. I think so. It's happening more than like distance squared. It's happening like distance cubed or distance raised to the power of 4. It appears to be significantly weaker and weaker whenever I point that light into the sky at night.
So the same concept of firing this thing will applicable here also. So what will happen is, in this particular case, even though the photons may be traveling, but intensity is so less for us to see it, we may not be able to see that where the photon has gone.
Sir, isn't like if I point it perpendicular to the sky, and if I see it, there are photons that are also traveling that distance to my eyes also. So it would be double the inverse square law, isn't it? it One is the light being going up the sky, and the other one reaching my eyes. So it would be distance raised to the power 4, I think so. Can this be the case?
You are trying to say that light is traveling up and down.
Yes, sir. Like to reach my eyes.
No, I don't think so. It should happen that way because that particular case, the speed of the light, what will happen to the speed of the light?
No, sir. Like if it just traveled straight, if it didn't bump into some things and got into my eyes, I would never be able to see that light because I'm not receiving photons, right?
If photon is being emitted not in just one direction, it's transmitted in all direction until unless you are pointing with laser or something like that. So if it's going into all direction, then some of it will come into your direction also because of atmospheric scattering. Okay. So what you are basically seeing is because of the scattering part of it, you are seeing a portion of the light. When you point a torch on the sky, the light may be traveling further off,
Yes.
but you are only able to see only a portion of it.
So, so like that light is going up and it bounced off of something and then reached my eyes. So uh, that is why its intensity got lower and lower, right?
Yeah, that's correct. So what is happening is light may be traveling a lot. Actually, the photon may be going further off than what you are actually seeing it. But because of the scattering and another thing, you are able to see a portion of that light.
Okay. So doesn't it apply like to inverse square laws, the one to reach that a particle which it bounced from, and one from the particle that it bounced from my eyes? So wouldn't we apply double inverse square law, so 1 by d raised to the power 4?
Actually, I have not thought about it. What will happen to the distance, particular these things? What comes to my mind is actually the distance traveled is same as inverse square law. What you are able to see is only a fraction of that particular distance.
Yes.
Well, let's say you are pointing a torch and the light goes, I don't know, just making up that number, let's say 5 kilometers. But what you are able to see is maybe just about half a kilometer or just few hundred meters. So actually what you are able to see is not the complete distance where the light is being traveled. You're only seeing a small portion of it.
Okay, sir.
And this particular thing is when we talk about inverse square is more to do with stellar light, the light which is traveling to us. It is more to do with that particular thing than
Okay.
actually
For
torch pointing somewhere.
so
So in
uh
that case, actually, what is happening is light is actually traveling in one direction only.
okay, sir. So I had one more question, that how do we measure an photons wavelength?
Photons wave. So, so
Like I
measuring any wavelength should be the concept should be similar. Measure the frequency, time, and you should be able to convert the frequency into wavelength.
Sir, but how would we be able to measure something as small as a photon?
Photon, I think, is it the smallest one? I think X-ray and other things are smaller, isn't it?
Yes, sir. These are their wavelengths are shorter.
So if you can measure wavelength of for shorter object, what is wrong with photon?
No, sir, like I'm asking, how do we do that? I know that with the current technology we can do that, but I do not understand how.
Most of the wavelengths are measured by scattering the light. Even from the other objects also, when we measure this thing, we are only measuring it by because of scattering of light. Even from the distance of the stars and other thing, whether the color of the light, everything is measured using scattering of light.
Okay, sir. So, scattering the light. So, how does that help us? Would do we just put that into a spectrograph and check?
Yeah, you put it through the spectrometer. It will actually bend different colors at different thing, and you measure those things and convert them into wavelength and other.
So, these. Okay, so there would be equations for this, right?
Sorry.
Are there any equations for this that you just mentioned?
Bernoulli's relation should be there, na? De Broglie equation.
I haven't heard about them. I'll try to search about them. So,
Yeah, you can talk about Louis de Broglie
oh, I've heard that
wavelength.
name before.
Uh, so he has a formula for calculating wavelength based on Planck constant and other things. You can use that particular formula. The lambda is equal to h over mv,
Oh,
where h is the Planck constant. So when you talk about that black body thing, when you study,
yes, sir.
then black body actually that concept failed because we assumed that the wavelength is continuous. It was only the Planck which actually said that at particular stage they travel in pockets. They are not. You cannot keep slicing wavelengths smaller pieces. So at particular level they just move in one packet. They don't move. They can't be sliced further.
Okay, sir.
So
So,
that's how we have that Planck's length or Planck's thing, the
uh,
smallest size in which it moves.
sir, I had attended a meeting about the three body problem, where we talked about these different types of problems. So, in the four body problem, what happened is that the speaker also included an radiation part, like the radiation coming off the star and then hitting it, and which pushes some of it back. So if we are including that minute things, so like if we push a door, uh, for the hinge, there are hinges and pivots, right? So wouldn't we account the kinetic energy lost, like by the force traveling in the particles and then reaching the hinge? If we are measuring that small in stars, why don't we do these things in the daily life?
Okay, can you repeat your question once again?
Okay, so my main question was that whenever we push those, the hinges act there are hinges right there, we which we use to move the doors. So why don't we include the part like where the atoms take the some kinetic energy, the small by the small amounts? So why so do we do that, like uh, in these physics types, if we
Actually, this three body problem is more to do with celestial objects. Okay. Now, when you talk about atoms, we are again going to quantum mechanics. So you are trying to draw parallel between classic mechanics and quantum mechanics. So that's where a lot of things actually fail.
no sir, I was just talking about how this question got into my mind. I was talking that in the four body problem, the speaker added an radiation part, and I was like, if we add these small discrepancies in these stars, in these objects, why don't we do it with our normal life?
That's what I'm saying. The two theorem are not interchangeable. Like what is true for quantum mechanics is more probabilistic in nature, whereas in classic mechanics there's a lot of things which are deterministic in nature. That means a lot of things we know, we can calculate, we know how things behave, whereas quantum mechanics a lot of things we don't know how it's going to behave. So the two laws are cannot be interchanged. You can't apply one to other.
But sir, I don't think so. Three body, the four body problem has to do something with quantum mechanics.
No, I
It's
don't know. I don't know about four body problem. I am only telling you because you are trying to compare, apply the three body problem into the concept about atoms and other places. It is based on that.
no, sir. I was like, if we are uh, taking in account for these such small uh, different amounts, so why don't we do that in the real world with everything else? Uh, so did you get my question?
Yeah, I got your question, but I'm not able
Yeah,
to provide answer actually.
Aryan, I'm not getting your question actually. Can you make it simpler than what you are saying right now?
Sir, whenever we push a door, the
Yeah,
hinges act.
and a bit louder also. Today my computer is not working well.
Okay, sir. So my question was that whenever we push a door, the force acting
Whenever
is
that word I not understand. Whenever you,
whenever we push a door,
huh?
what happens is that the hinges act, right? So
What
why
happens
don't
that it what
the hinges? Uh, how would I explain? The hinges where the door works, right?
right?
If we push a door, so why don't we include the energy lost, like the kinetic energy lost by the particle interactions? Like if we push a door, what happens is that some of the atoms also absorb that, right? So why don't we include that into the equations and stuff?
No, no, I mean, why you want to include that? I mean, you see, first of all, you see all the physics problems which are there in the world. The general procedure is you break a complex system into simpler systems. First we try to understand the simpler one.
Okay,
Like
sir.
say, for example, a pendulum is swinging. See, most of the time we take only the first term into account, but there are many, many more terms are there, which uh,
So
first you understand the simplest one and the most the major one. Then others, then you try to understand. You break a system into simpler systems. You understand each one and then combine them and let us see how they behave. Things like that. That's the usual procedure in physics, in chemistry. Biology people, I do not know how can they do like that, but they must also be doing like that because you can't, have many systems. It becomes a many parameters thing. So to make a model of that is a very difficult thing. So always simplify a model, understand from the simple to the complex. So
okay,
if someone is interested that when the door moves, you must take those molecules also into account. If it is of interest, he will try to study that. If it is not of interest, he may not study that.
oh, so I got
The
this
scientists
question.
already have too many problems to answer.
Oh,
So a door having, how does it matter? If it matters, they will try to understand that. Even when you grow big, you will try to understand that. If it doesn't matter, or if it is a very minimal concern, they do not go into it. So there are still so many problems to be solved.
sir, I got this question by attending an lecture on the three body problem.
Yeah, what is this three body problem, by the way?
No, sir, I was just, it's about when three bodies of identical masses get into a gravitational field with each other. So when the speaker was presenting that, there was also the four body problem where he included the radiation part. So I thought that if we include these such small discrepancies, why don't we do that in the real life?
Yeah, if that interests us, then we do it. But already, since Newton's, people used to study the combination of Sun, Jupiter, Earth,
Yes.
Sun, Jupiter, Earth, Mars. These combination, how combinations, how they move. You know, th- because that was of interest. To predict the movement. But wherever it matters, people will study that. You can suggest, I mean, wherever it is there. But the most important thing about two body and three body, like say hydrogen atom, if you read quantum mechanics, you will find they'll teach you how does hydrogen atom behave. But they cannot do helium because as soon as more than two are there, it's very difficult because you have to monitor the distances, you see, of so many bodies, so many parameters will come into the picture. The equations become difficult.
Okay, sir.
But wherever it is necessary, people have to do it. When you grow big, they'll teach you quantum mechanics, means they'll start with hydrogen atom. Why? Because there are only two bodies. एक प्रोटॉन एक इलेक्ट्रॉन खिस्सा खत्म थोड़ा
So,
जो ही एटम बड़ा होता है इसके बाद it becomes so difficult to even solve that equation. I still do not know if people have solved even for helium. Udayji, are you aware? Because at least after my college, I haven't seen it.
So even I
Has
have
the
never followed all this.
helium atom been solved
No, I have not.
completely, perfectly? I think no, it's very difficult really. But approximations have been made. Till
so,
helium, approximations have been made which are very nearly correct. Theoretically, approximate behavior, I think, has been done. And nowadays, you should be careful. These YouTube, they are sending out pictures of hydrogen atom, which I don't know where from are they getting it.
so,
Udayji, have you seen this YouTube? No, there are so many channels. This is the picture of hydrogen atom, how it looks.
No, I have not seen it. But yeah, I agree with you that YouTube, everyone is creating a lot of.
Yeah, yeah. And our young children will get completely misinformed, and their whole thing, the sense of physics will go away actually. And they say they give good names. It was done there, Princeton University, there, all foolish things.
No, even if it is done at some place, that does not. A paper in itself is a classic example that everyone talks about is cholesterol. Okay, the person who published this paper, I don't know, I'll just Google and see his name. He had a data of 29 countries. He used data of only 7 countries, which supported his line of argument.
Acha.
Okay, and thereafter they said cholesterol is bad, and now they realize that the people who stopped reduce their cholesterol levels are the one who are suffering from dementia. So now they are trying to correlate dementia with cholesterol. So now they have over a period of time said, no, not all cholesterol is bad. There are good and bad. And now they are saying there's nothing bad about it. It's just the name. What is then there in the name? So anything which body produces cannot be considered bad. And about 80%, 90% of the cholesterol is produced by your liver.
Oh yeah,
So,
that's a good news. So I
so
can
what I'm
have as
saying,
much of eggs as much as I like, is it?
yeah, that's what I'm saying. Your if your body has too much cholesterol, your liver will produce less. If your body has less cholesterol, your liver will actually produce more to catch up the requirement. So I'm just saying, unlike physics and chemistry, biology does not work in one particular direction. It is multi-direction, multifactorial. So every time your body is trying to reach a particular perceived standard. So whenever something gets disturbed, you increase something in your body, you reduce something in your body is trying to readjust to that equilibrium, homeostasis, that is trying to reach a equilibrium. That's why we have
Mm.
withdrawal symptoms, because if you start taking unwanted thing in your body has stabilized to the new normal. And the moment you withdraw that drugs or alcohol, the body has to again gone out of that equilibrium.
Oh, that's that is. Thank you very much. I think this is a very nice information actually, right?
so, sir,
And similar things also happened with this homeopathy. Do you know the history of that one? In 2008, a French scientist published in Nature that uh, you see homeopathic medicines which are there. So number of dilutions which they make itself, whether it is doubtful whether a single molecule will be present of the medical means item medicine, even single molecule will be difficult to find out. They make 6 million times dilutions, 1 million time dilutions, things like that. And so that
Exactly.
gentleman in 2008 published in Nature that it is a memory effect.
Yes,
Do you remember this case? This was
Yeah, I've heard of such things, but
yeah, yeah. So what he said is that Miss Molecule, while diluting the molecules which were there, they are gone now by dilution, but they have left their imprint in their solution. So when you take that, it helps you how to. It helps in your diseases and fight diseases and things like that.
sir, I've heard about
And
it.
yeah, yeah. And then later on, it was found, and it was published in Nature of all places. It's only when the people try to duplicate that experiment, they found there nothing like that is there. There is no memory effect, there is nothing. And then that gentleman was forced to withdraw that paper.
so that's
Most
what I'm
people,
saying. They said
yeah, most people say that
they,
it was the homeopathic companies that instigated him to do all these things.
Yes, sir, it has to do something with there's a measurement they call I think so C. So one C is 1:1.
100, 100. See,
C.
one C is 100, yes. And if it is M, it is million times.
Yes, sir.
In fact, if you dilute it,
One
it's
X.
something like 20 times or 25 times, hardly a molecule of that thing will be present.
Yes, sir. There is also an X, 1X, 2X.
Yes, 1x, 2x.
So they dilute it.
Do you take homeopathic medicine, Aryan?
No, sir.
Never, never. In fact, it is just a placebo reaction. Do you know what is a placebo reaction?
Placebo. Yes, sir. Which
Yeah.
thinks like it's curing the disease, but the body was doing that.
Yeah, body was doing that, but once you take something feeling that it will do something good to
It,
you,
it
it
got the
helps. It helps, but it doesn't actually, I mean, doesn't play part in curing that thing.
yes, sir. It just takes that credit.
Yeah, and it is the use of homeopathy is prevalent in South Asia. Now it's from Europe, it is declining. In Britain, it is declining. Many homeopaths are there.
Sir, have you heard about Monsanto?
Monsanto.
Yes, sir.
What is that?
Sir, it's an I think so. It's an seed producing company.
yes, yeah. I've heard some videos also of some lady talking about this.
Yes, sir.
Wh-
So
What it does?
it produced seeds. Uh, I think so. It also gave insecticides and that stuff. So like it runs most of the farms. Like it it majorly rules all the Americas farms.
What, what is the spelling you said? Moon, Moon,
No, sir. MON
and then
Mon Saturn. I think so. Mon SA.
I'll take a look at that. What is that?
I'll also type that just into it. Mon
Oh,
Santo. I've typed that.
okay.
Yes, sir. It is MONSANTO. I think so. I think so. These things happened in your time period only.
Mm-hmm.
So
No, there are people in USA also. They believe quite a lot in homeopathy. Yes, it is there.
yes, sir. So sir, I am also very astonished by the work of biologists. They figure it out where they figure out some things like which are very hard to understand, which have third parties involved. Like it has a lot of third party factors. In biology, has a lot of third party factors. So getting to know what thing caused it is uh, is an art. I think so. It's pretty hard.
Mhm. So you have to be very careful. Once you learn science, you have to be very careful in your life that what is a fact and what is not a fact.
So I'll just say there is a particular uh, publication by Nature and Lancet. Okay, so every time when I talk about top five journals in anything, and especially medical, is like this. There is a website called Retraction Watch. I teach my students about uh, this particular website and this particular thing. First thing I ask them to look for the top five journals publications, and once they pull out Nature and Lancet, then I say, look, there are people who have published paper in Nature and Lancet after a lot of scrutiny, 5-10% acceptance rate, and after some 4,000 citations, the paper is corrected, thereafter withdrawn. So a lot of time and a lot of things published, like the first person who published the data for cholesterol, he had data for 22 countries. He only used 7 countries which support his line of argument. So depends on which lobby is trying to push through. They blame it the
Yes.
sugar lobby actually to pushing through this particular concept. So a lot of things in biology, what happens is because it is multifactorial, there is no one cause. Like I'll give you example, and everyone is scared of health. So maximum research happen in the field of cancer because everyone is scared of cancer, and maximum fraud happens in the field of cancer. Okay. The next thing is when we talk about food industry, there was a study done on rats. Rats, everybody like they have found out that only humans have a lot of cancers. The bigger animal and the smaller animal do not have cancer, and they have found why they do not have cancers because you require a critical mass for it to support. So for bigger animal, they get killed. Like elephants and others do not have cancer. That is the study they have done. Now, what happens on a rat, because rat is small animal, will not happen to human beings. But the experiment was done on a rat regarding their effect on heart, and it got published. It was never done on human being because of ethical and other reason. Now, the company who got benefited is a Canada-based company.
Mhm.
They use something called rapeseed oil in place of mustard seed. They named it canola oil, and they're the biggest beneficiary. Now, mustard oil, once it got published, India, which was a self-sufficient in edible oil, has become net importer for last 50 years. Nothing is wrong with mustard, but people have stopped eating it. They started eating sunflower oil, which is has to be imported, palm oil, soybean oil, which is not produced in the country. And India is spending so much. So a lot of research paper are done by the food industry to demonize food habits of developing countries, and by finding some vague research, that research is out of the thrown out of the window, but it remains in the mind of common people. So they
Yeah.
stop eating that particular food. So a lot of paper, when you see those papers, you must also be skeptical who's funding it. Because I tell my student also, don't blindly read the paper. Find out who is funding it, what type of data, what is the sample size. Study on 10 people, 20 people is totally irrelevant. And another place where a lot of fraud happens is psychology. When two
Oh yeah.
twins don't think alike, 90% or 95% of all psychological study have been done on white male this thing. And what a white male thinks, they assume that everyone is supposed to think same way.
Mm.
Whereas our brain is trained to see things around us. Our brain is trained by story from our ancestors, from friends. It's like everything we see on day-to-day life, we build up our own story. When we build up our own story, everyone thinks differently. If everyone thinks differently, how can a psychologist apply a logic of a white man which thinks different from a black person, or from a brown person like us or Indians others, and apply the same logic? They must also be doing this. They must also be thinking this. And in fact, now people have started filing a case on psychologists because their condition have deteriorated by taking that advice because they think different. You're conditioning everyone into think. Psychologist is also trying to condition everyone to think into one way, and
Yes.
that way is white male way of thinking. If you're not thinking that way, there is something wrong with you.
Oh my God, you see, people have to be really very careful.
Hmm.
Sir, I had one more question.
Yeah, go ahead.
Sir, like as we know, the visible range spectrum is 400 nanometers to 700 nanometers. So how did we
Yes.
check it?
How do we check it?
Yes, sir.
No, that is a visible spectrum. So whatever we can see, first of all, it's a continuous wave which is traveling. They are traveling at different wavelengths. There are certain wavelengths we can see it, certain wavelengths we can't see. Certain wavelengths we can feel it. Like infrared, we can't see it, but we can feel infrared. If
Yes.
you go further lower frequency, it's the thermal range. If you go further less, it is that microwave frequency. If you go further less, then there are radar frequencies,
Okay.
which
Sir,
are also depend. Mhm.
like did we have a person like test these out? Like one person said this is 500 nanometers of light. Do you see or this or not? So that is that how we do it?
No, no, you can't. No, that's not the way. We, you know what is frequency? Number of cycles per second.
Yes, sir.
Okay. So number of cycle per second of frequency and wavelength are inversely proportional. If there are more cycles per second, then the size of the wavelength will be small.
Yes.
The smallest wavelength is what we call it sound waves, which is also pressure wave. So smaller frequencies are generally at a this thing. We can hear smaller frequencies. Provided it's pressure wave, we can put pressure on here. The same frequency which is not pressure wave, we can't see. But there are different long range frequencies. The even radio frequencies are supposed to be uh, low frequency and longer wavelengths because they have to travel a larger distance. Radar, depending on the type of radar used, can have less than radio, but different types of frequencies. Like the older system used to have the frequency like used to call L, S, C, X, Ku, those bands, which used to be 1 to 2 gigahertz was L, 2 to 5 was S, 5 around 5 was C, 5
Sir.
plus. So
Okay.
this frequency is used for radar. If you further go up, it becomes thermal waves, heat waves. So what we can see, if you can measure those, that is 400 to 700 nanometers. This is the frequency we can see or corresponding wavelength. These are the 400 to 700 nanometers. Convert them into frequency. So what we can see if we measure the frequency is that much.
Sir, but how
And
did we do it?
Aryan, no, no, our eyes are sensitive, say from 400 to 700. There are some human beings, they don't see a particular color, you might have heard. There are some animals, they see more than that. So some of the animals, they can see ultraviolet rays. They go beyond, but we can't see that.
It, okay, sir.
And there are some animals, they see only black and white. It's very interesting, actually.
So our eyes are sensitive to particular
Yeah,
band of wavelength. That is what is 400 to 700. This is what our eyes can
yeah.
sense. So
So
it's
this
not
is
an
a,
arbitrary figure. If your question is it arbitrary figure? No, it's not an arbitrary.
the evolution has brought us to this kind of thing, that we see only the 400 to 700. So there are other animals. Maybe in future it might extend. We don't know.
No, otherwise
Now
also
we
what
don't.
otherwise
Yeah.
also what is happening? There are certain animals which, like in daytime, there are more blue lights, and in the night there are more red lights. There are certain animals which can see on the lower end of their this thing, uh, depending on whether we are talking about the frequency or wavelength. So if you are talking about uh, 700 plus, red has higher wavelength and lower frequency. So if there are animals which can see in the night, that means they must be seeing in the red and infrared region than in
Yeah,
the
yeah.
blue
Like
spectrum.
the owl, like the owl.
Hmm.
Owl has a
So,
very extended range of, the uh, vision actually.
so they must
They
be
can see
good at.
very clearly in the night.
So in so their I must be sensitive more towards what you call it 700 800 nanometer range.
Yeah,
Same thing happens.
I do. Yes, I don't remember, but it's a very wide range as compared to us.
Yeah, so I don't even, I'm just making up that number because that's what happens in the night. Night is more reddish. This thing. Day
Yes.
is more of a bluish color. So because of the brightness that we see, the animals we see in the daytime, they see more towards that spectrum, 400 to 700, or there may be some animal which can see less than 400 nanometer range. That is ultraviolet range.
Yeah, but there are some they can see ultraviolet, and the bat also has a very interesting range.
And this is not only true for our eyes, even for our nose, ear. There are like we hear between 20 to 20,000 hertz. There are animals which can hear lower frequency, like and dogs animal can hear the earthquake. This thing. So they similarly they smell. They can smell things which are from very faint smell. There are a lot of smell we don't perceive it because they are so faint. But dogs can actually sniff it. They can smell those things. So one of the reason why dog is used a lot because of their wide range of smell. This thing they can
Yeah.
smell wide range of things. Similarly, there are
Exactly.
animals which can hear the uh, when the earthquake happens, like in this place, about few years back, close to Dartmouth, there was an earthquake around 400. This thing, we heard the sound before we heard the vibration.
Hmm.
So
Right.
the epicenter was just about 7 8 kilometers, 7 8 miles from here, or 10 miles from here. It was so close. So what I'm saying is the earthquake also produces a lot of sound. The sound waves travels. So there are animals which can hear the sound wave before the actual earthquake happens. So whatever they started all hauling or whatever they do to make sure they can communicate to their group that something wrong is happening.
Yeah. So
Even
Aryan,
animals,
it's a very
animal,
interesting world.
yeah, even animals during tsunami they start moving to upland. They actually they had the knowledge that something is wrong is happening. Earthquake has happened now. Tsunami will happen. So they started moving uphill. So there are animals who had knowledge about tsunami and they used to take corrective actions.
चलिए अब हम लोग छुट्टी करते हैं अब.
हाँ, जरूर जरूर.
Yeah.
ठीक है फिर. Thank you.
Yeah. Okay. Wish you all the best. Have a nice
Thank you.
weekend, all of you.
You too. Bye.
Bye, sir.